Today I'm going to be demonstrating how to classify soil based on texture and structure. Texture is made up of 3 different particle sizes: sand, silt, and clay. Sand being the largest, silt being the middle ground, clay being the finest. Different percentages of those 3 particles is what makes up the different soil textures. Whether that be sandy clay, silty clay, clay, fine sand, silty clay loam, the list goes on. Structures are what are formed in the profile over thousands of years, and it's the shape that the soil aggregates make in the profile naturally. Granular is usually found in the topsoil. Blocky, columnar, platy, and massive can all be found in this subsoil section, which is where I usually do most of my work. Parent material and bedrock is more about geological formations and not necessarily soil texture and structure. Texture and structure of soil is what determines how water and wastewater can move and are treated. For those purposes in my job, I use that for environmental planning on projects where people are wanting to develop land. To save on time, I already took samples in the field. These came from a profile that I already did a couple days ago. Normally, I would be in a 5 to 6 foot deep hole. I'll say 5 foot because I'm not supposed to be in a 6 foot deep hole. And I would have a tape measure and a soil knife. As I'm in the pit, I put up my tape measure and I look at the different layers of soil and where those breaks are naturally with the color. I mark those. Then I take my soil knife and I would work down the profile. So down the profile, feeling for the different changes in texture, which is actually very easy to tell. Then I'd mark those. Each of those are put into a plastic baggie and marked at the depths. This is where I would go ahead and make any notes about any water table that I've seen or any sort of rocks that I would see as far as geologic formations or roots. Those would be taken back to the office then to figure out the structure and then the texture. I would have a report that I could write each of these depths down on, and as I'm opening these up, I take an aggregate, or a PED is what we call it, if I can get this open, and it would go in my hand like this, and I just naturally break it. Naturally break it up like that. And as you do that, you can see that it takes certain little shapes. This one would be granular. And that goes back. On my report, I would mark 0 to 5 inches, granular. This is my next. This is a good example of blocky. As you open this up, that's actually one that I already worked up. As you would break this open, you would see that just naturally, without even trying to make it look like blocks, it forms blocks. Most of the soils in Kansas, we're going to start getting into some more massive, at least in this county, we're going to start getting into some massive structure now. Sorry, this is not open correctly. This is some heavier clay here. So when I take this out, and this is where I started seeing water table in the profile out in the field. I break this up and it has the same blocky structure, but it's weaker. And that will change how I rate this soil. This last, well, we're not at the last one yet. Second to last one is where we started getting into the massive structure. Meaning when I was down in the pit, there was nothing. It was just a big wall of soil. I'm not going to even pull this one out because it's mud. We hit water table. But that was massive also. On my report, I would write all those down for each depth, and then we would go to figuring out the texture portion. This gets messy, so I'm not going to do this on my speech because we would be in a muddy mess. But what we would do is you'd have to have a water bottle, and you would take a nice chunk of it in your hand, like before, and you'd wet it. And you'd wet it. And then you'd keep wetting it as needed and breaking it up until all the aggregates are broken up, and you can kind of have it like putty. Once it's at that texture in your hand, the putty, you do what's called a ribbon. Equal pressure between both your thumb and your forefinger until it breaks naturally. Once it breaks naturally, that size that ribbon is what determines where we start at on this triangle. This would be a silty loam. I'll move to one down the line here. This is a silty clay. This is a lot more difficult to work up. But as you see, once we start ribboning this, I think this one, when I did it, was about 8 inches long, which is actually more just like clay, not silty clay. That determines that. Then we would go and write that down on our report for each depth. The next step is you go back to your first one, and you put just a little bit in your hand, and you're going to wet it generously. And when you wet it, and you do this with your finger, and you rub it in your hand, it's going to break down all of those particles. And you're going to be able to feel if it's gritty, then it's sandy, basically. If it's feathery, and it feels kind of feathery, I mean, it's a weird feeling, actually. It feels velvety to me. That's silty. If it doesn't feel either, that's just clay. And then you're going to work your way through here to figure out what that is. This is the silty clay loam, granular structure. Silty clay, blocky structure. Silty clay, blocky structure. Silty clay, massive. Silty clay, massive. Well, I hope this gives you some more insight into what I do and the fact that dirt is not just dirt.
And our audience,
that's my audience,
is me, Sharon. Hi.